Hi, this is the second video in the playlist where we're looking at the paper 3 and it's November 2017 Edexcel paper. It's the higher tier paper. So in the previous video we completed through to question number 7. So in this video we're going to start from question number 8. Please do stop the video, have a go at each of the questions and then compare your solutions. Okay, so in video 8 we've got some people who for some reason drop a drawing pin a number of times. I've no idea why they would do that, but they do. So Lucy, Mel and Tom are each dropping drawing pins. So what we're saying is that Lucy drops her drawing pin and it lands 31 times point down and 14 times point up. So in other words, 31 out of 45 it lands point down. She actually drops it 45 times in total. And it's the same with Mel, 53 times out of 80 drops, okay, and then 16 times out of 25 drops, okay. So the reason I put that bit of information in is because I'm pretty sure that that's the kind of thing that we're going to be talking about in the questions. So Rachel is going to drop the drawing pin once. Whose results will give the best estimate for the probability that the drawing pin will land face up? Okay, well, it's going to be Mel. Now, the only reason it's going to be Mel is because she actually dropped her drawing pin 80 times as opposed to Lucy 45 and Tom 25. Okay, so if you drop it more, you're going to get a better indication of the probability. So in this particular case, it would be Mel because she dropped the drawing pin more times. Okay, all right. So then it says Stuart is going to drop the drawing pin twice. Oh my gosh. Okay. Use all the results in the table to work out an estimate for the probability that the drawing pin will land point up and for the first time and point down. Okay. All right, so let's have a look. All the results from the table. Basically what we're saying is if we add up the points down, it's going to give us 100. Okay, and if we add the points up, it's going to give us 50. Okay, so what we're saying is it landed point up 50 out of 150 in total, and it landed point down 100 out of 150 total. Okay, so let's just put that into the actual text itself. So what we're saying is that point up, okay, it landed 50 times out of 150, and then point down, it landed 100 out of 150 times. So if we want to find out the probability that it's going to land point up and point for the first time, point down for the second time, we multiply these two together. It's paper 3, so use a calculator on that, or you can do this by arithmetic, but basically you should end up with 2 9ths. So actually the answer to this particular question will be 2 9ths of the time. Okay, I hope that's all right for you. Let's move on then to question number 9. If you're not sure about any of these questions, please do leave a comment below. I will always come back to you. Have a look also at the channel. There are playlists that will give you examples of similar sorts of questions. Okay, so Jack bought a new boat for this. Okay, the value of that was that. Okay, at the end of how many years was the value of Jack's boat first less than 50% of the value of the boat when it was new? So in other words, what we're saying is how long will it be before the value of this boat is £6,250? In other words, half of that value. Okay, so I'm going to take a guess at this point. What I'm going to say is actually, we'll say after 4 years, I can use the formula, and I'm saying it should equal 6,250 there or thereabouts. So 12,500 times 0.85 to the power of 4. Now what that actually gives me is slightly more. It actually gives me 6,525. So actually, no, sorry, that's not going to work. But I'm probably onto something here, so I'm actually going to use 5 years. Okay, so in 5 years' time, I'm looking for 6,250. It equals 12,500 multiplied by 0.85 to the power of 5. What do I get? Well, I get 5,546. Excellent, so that would work for me. So the answer to this particular question would be after 5 years. Okay. All right, hope that's okay for you. So on to part B of the question. It says a savings account pays interest at a rate of R%. And this guy invests 5,500 in the account for 1 year. Okay, at the end of the year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.20, work out the value of R. It's actually quite a good question, really, because there's a couple of different moving parts within this. So what we're basically saying is that if he pays tax at the rate of 40%, then the £79.20 is only equal to 60% of the actual interest payment. Hopefully that's okay for you. So we're saying £79.20 is only equal to 60% of the interest payment. Okay? Because he's already paid 40%. So therefore what we've got to do is figure out what that payment would have been in the first place. So let's put this into kind of mathematical terms. We're going to say 79.20 is equal to 0.6. So all I've done is change that percentage to a decimal of the interest. So if I divide through by 0.6, I'm going to get my interest payment to be £132. Okay, it's one of the topics that we look at is called reverse percentages, and this is actually a reverse percentage question. Okay, so let's now have a look at trying to work out the value of R. Okay, so what we do know is that the interest he's going to get is going to be £132. So basically, at the end of the year, he's going to get £5,632 when he invested £5,500. Okay. Again, hopefully that's okay for you. Now that's multiplied at the end of the year by the multiplier, which is the bit I'm interested in, for 1 year. Okay, so if we now divide that through by, if we divide that by that, we're going to get the multiplier as being 1.024 multiplier. Okay, and that's the period of 1 year. Okay, well remember that this means 102.4%. Okay, so this bit of it is equal to 102.4%. Okay, so 100%, because it's compound interest, 100% is the original 5,500. The actual multiplier, the value of R, is going to be 2.4%. It's the bit on top that the bank have given to Jack because he's given them his 5,500. Okay, so in this particular case, the value of R will be equal to 2.4%. Okay, I hope that's okay for you. Just takes a little bit of explanation, that particular one, but it's quite an interesting question and I think they've done quite a good job there. Okay, let's move on then to question number 10. Okay, and again, please do stop the video, have a go at each of the questions and see how you get on. So these are fairly popular type of questions that deal with probability. So at the moment, we've got this blue, yellow, green and red counters. Work out the probability of getting a red counter. Okay, fairly straightforward because all of these probabilities added together need to equal to 1. In other words, a certainty, because when this particular person takes a counter out of the bag, it's certain they're going to bring a counter out. So what we're saying is if we have 0.20, which is blue, 0.35, which is yellow, 0.40, which is green, that should add up to 1 whole. Well, it doesn't. It adds up to 0.95. So the difference between that and 1 whole means that red would be 0.05. Okay, so the probability of getting a red counter would be 0.05. Okay, then it says, what is the least possible number of counters in the bag? You must give a reason. Okay, so let's have a look at this. So what we're saying is that if the probability of getting a blue is 0.2, that's 20%. So we might as well actually use that as being a way to kind of work this out. So we're saying that blue would be 20%. In that case, let's say there's 20 counters in the bag, which would mean yellow there's going to be 35, green there's going to be 40, and then red there's going to be 5. Okay, right, so we could have 100 counters in the bag, 20 of which would be blue, 35 yellow, and so on. Okay, but the question is asking for the least possible number of counters in the bag. So actually what we can do is divide this through by 5. Okay, because if we divide this through by 5, it means we could have just 1 red counter, 8 green counters, 7 yellow counters, and 4 blue counters. Okay, so the reason that's the case is because the 5 is the highest common factor. So I can put 5 is the HCF of 20, 35, 40 and 5. So in other words, the minimum amount of counters that we could have is going to be 4, 7, 8 and 1, because I can divide each of these numbers by 5. Okay, hope that's all right for you. We're going to move on a little bit. I'm about halfway through the video at the moment. We're going to aim for about 20 minutes or so. And if you do try each of these questions, it should give you round about an hour's worth of focused revision on each of these topics. Okay. Okay, so on to question number 11. And question number 11, I'm going to just put it on the video as far as the actual graph is concerned. However, if you do get the chance to download the paper, please do have a look at it. The first thing is it says use the graph to find an estimate for the median weight. Well, as you know, the median weight is the middle, in this particular case, potato, the middle potato. But what you might spot is that actually the only information we've got is 2 potatoes up to 60 potatoes at the top here. So the median potato is going to be the 60th plus the second potato divided by 2. So that's actually going to be the 31st potato that we're looking for. So if we go back to our graph, if we take 31 along here, okay, and then basically read it from the actual weight here, and we're going to get a weight of, in this particular case, I've got 57 grams. However, they will give you a little bit of leeway on those sorts of readings, so don't worry about it too much. Okay, let's have a look at the next bit then. So it says, General says that 80 minus 40 equals 40, so the range of weights is 40 grams. Okay, well, on the surface of it, that seems to be a reasonable idea. However, this is a cumulative frequency graph. So because it's a cumulative frequency graph, the information that's taken is taken from class widths. So because it's taken from class widths, it means therefore that the maximum weight of the potato might not be 80 grams in this particular case. It could be 79 or whatever their class widths are. And the lowest weight might not be 40. It could be 42, something like that. So I would just put a note in here, and obviously just in the interest of time, you might want to expand this if you wanted to, but I would put something like cumulative frequency graphs use class widths. Okay, So you might want to give an example of that and just put a little bit more detail into that. Okay, so part C of this, it says, show that less than 25% of potatoes have a weight greater than 65 grams. Well, let's have a look and see what's happening at 65 grams. So hopefully you can see that as well. We've got 65 grams at this particular point. So if I just take this line all the way up, okay, it's going to take me to there, and then that's going to take me across to something like that. So in other words, this particular point is actually the 49th potato. Okay, so in other words, between 49 and 60, there's only 11 potatoes. Okay, so what we're saying is 11 out of 60, because there's 60 potatoes in all, then that should be greater or less than 25%. Well, actually, if you use a calculator, then that's going to give you 18.3%. Okay, so actually only 18.3% of potatoes have a weight greater than 65 grams. Okay, so we're about another 5 minutes or so to go on this particular video, so we'll have a look then at question number 12. Please do stop the video, have a go at each of these questions, and then compare your solutions. Okay, so this particular question is a little bit complex, but it says Alan has two spinners. There's spinner A and the spinner B. Probability to land on red is that for A, and probability to land on red is 0.6. Okay, so then it says Alan spins A once and he spins B once. He does this number of times. The number of times both spinners land on red is 24, and this is a key issue here, because actually the probability of landing on red is going to be 0.25 times 0.6, which is going to be equal to 0.15. So basically what we're saying at this particular point is the probability of all of the spins landing on red is going to be 15% of the time. So we can use that bit of information to find out how many spins we actually spin in total. Okay, so if we say that red equals 0.15, now actually as a fraction 0.15 is going to be 3 out of 20. I just kind of find it a little bit easier to work in fractions for me, because I can say that 24, which is where it does land on red, is equal to 3/20 of the total number of spins. Well, if that's the case, then I can divide through by 3, therefore 8 equals 1/20, and then if I multiply by 20, what it tells me then is that 20/20ths, in other words, the whole amount of spins, is 160. So the spinners must have been spun 160 times. And we can use that information now to figure out how many spins it takes to land both spinners on white, which is the particular question. Now, just for the sake of completeness, I'm kind of going to work this through, but white is actually the one right at the very bottom, but I figured just for this video, I'm going to put everything down. So I've got red, and what we said with red is it's 24 times, okay? And the reason it's 24 times is because 0.15 multiplied by 160 equals 24, so that would be red. Okay, so let's look at red-white. Well, again, if you go back to the diagram, you've got red times white is going to give you 0.1, so this is red-white. Okay, so again, we can say that red-white is going to be 0.1 times 160, so that's going to be equal to 16, so red-white will be 16. And basically we're just going to carry on working through this. So we've now got white-red, okay? So white-red is going to be 0.7 times 0.6, which is going to be equal to 0.45, okay? So we've got white-red, and that's going to be 0.45 times 160. Well, that's going to give us a total of 72. Okay, so white-red is going to be 72 times, okay? And then the final one, which actually answers this question, is going to be white, and that's going to be 0.7 times 0.4, and that's going to give us 0.3. Okay, now there's a couple of just little stops here that we just check. I'm sure you appreciate that we need to make sure that these all add up to a certainty of 1. So if you add up all of these, you're going to get 1. So that would be perfectly correct. Okay. And then also we've got to make sure the total number of spins adds up to 160 because we worked that out. Okay, so let's look at white. So white we said is 0.3 times 160, so that's going to be 48. Okay, and actually white, which equals 48, is the answer to this particular question. So I can say white equals 48. Okay, so I'm just going to check that. If I add up all of these numbers, I get 160, so that would be perfectly correct with this particular question. Hope that's okay for you. We've got a couple of minutes, so we'll just complete at question number 13, which is a completing the square type question. These generally tend to be quite popular. They do pop up in these sorts of questions, in these sorts of exams, so it's well worthwhile making sure that you've got the technique okay. So what we do is we say, well, we're going to do x squared plus 6x. I'm going to rearrange that as x plus 3 squared. So the technique is that I square it and I halve this coefficient. Now, I'm sure you appreciate that if I multiplied x plus 3 times x plus 3, what I'm going to end up with is going to be x squared plus 6x plus 9. So this part of it is absolutely fine. This is what we're looking for, but of course we've got to get rid of this plus 9. So what we're going to do is minus 9. Okay, and then the final little bit of this is going to be the minus 7. So if we minus 7, and then we just literally write that out now, we can say x plus 3 squared minus minus 9 minus 7 is minus 16. Okay, so if you want to be clearer for the examiner, then you can say that A equals 3 and B equals minus 16, and we're writing it out in the form of x plus 3 squared minus 16. Okay, and that would answer that particular question. Okay, so I hope this series of videos have been useful to you today. Please do comment below. I'll always come back to you. We're going to start the next video from question number 14 onwards, and I look forward to seeing you inside the next video.